Hi everyone, welcome back to Portfolitics 1.0. This is our second lesson in our third project. In this lesson, we are going to be taking a look at some exploratory data analysis and hypothesis testing on our generated YouTube video data. Some of the exploratory data analysis that we'll be looking into includes summary statistic for some video performance metrics like the views, the likes, the comments, and duration. Likewise, we'll be looking inward to the distribution of video duration, and also we'll be looking to Alex top 5 videos by views, likewise the top 5 videos by engagement. Then we'll be comparing the metrics correlation, I mean views, engagement, and duration. We'll also be looking into the quarterly view trend on Alex channel. Then finally we'll look inward to the most common keywords in Alex top 10 viewed videos. Then afterward, we'll test for some hypotheses like shorter videos have higher engagement. These are null hypotheses, so we'll test if it's correct or not, if we will reject it or not. We'll also test for Alex video published on some specific days if it performs better than the other. Then finally, we'll also look into tutorial videos get more views than career advice video. This particular last hypothesis here will serve as our assignment for the project. We'll do that one personally to verify if this particular hypothesis, this null hypothesis, should be rejected or not. Alright, let's move ahead. This is where we stopped in our last video, where we generated the video data on Alex YouTube channel. Then in our previous video, we had about 354 entries, that is 354 rows. However, when I run the notebook, I found out that Alex has uploaded a video, making it 355 in total now. So without wasting much of our time, let's go ahead with the exploratory data analysis. Here is our data. Let's view the first 5 entries in our data. Shift enter. Alright, we have the title, we have the views, we have the likes, we have the comments, and we have the duration and published columns. As we can see here, the duration columns, it's not that looking good, even though we can read it that this particular video, how to lie with data, it's about 5 minutes 18 seconds long, while this other video, 1 million YouTube play button unboxing, is about 7 minutes 40 seconds long. But it's not quite appealing enough. Let's convert this particular column, duration column, into seconds. So for us to do that, we'll be making use of some regular expression in order to extract the numbers over here and convert them to seconds. So let's move ahead. The first thing here is to import the regular expression library by simply saying import RE, shift enter. Then we can define a function to do that for us. Let's simply say the function name should be duration to seconds, and the parameter that we'll pass in here is the duration column. Let us look into our data. Some of our Alex videos are are not just only in minutes like we saw over here, as we are seeing over here, like 5 minutes, 18 seconds, 7 minutes. There are some of these videos that are hours in number. Take for instance, let us view the first 20 videos over here. Shift enter. Alright, as you can see, take for instance this particular video, Ultimate Data Analysis Bootcamp. It's about 24 hours, 23 hours, 32 minutes, 48 seconds. We'll be taking care of all those videos lengths, video duration that are more than an hour. So for that reason, we'll start from hours. Then we use that search function in our regular expression and say whenever we see a digit, and next to the digits we add a H letter like this, just like the one we saw here. That is, what this is simply implying is that whenever we have a digit before this particular letter, that is letter H, it should pick out the digits, then that is, it should search for this particular Regis expression in the duration column. Likewise, we'll do the same thing for the minutes and the seconds duration. So let me simply just copy this and paste it, Ctrl V, and the final one, Ctrl V. So afterwards, since we are willing to convert all these hours, minutes to seconds, we can simply define an if statement for that. But before doing that, let's initiate our total, that is the total time in seconds. Let's initiate it to 0. Then let's say if hours, meaning that if you have any value in our duration column in hours, what should you do? We should convert it to seconds, right? So that will be total. Our total then will be plus equals, we'll convert it to an integer format. We'll say hours dot group, then we'll convert it to seconds by simply multiplying it by 3,600, and R is equivalent to 3,600 seconds. So afterward, we'll do the same thing for minutes. That is, if minutes, the total now should be also in integer, then the minutes dot group 1, then we'll multiply this by 60 because 60 seconds make a minute, so we'll multiply that by 60. So it will also add it to the total, to the total over here. Then finally, if this is in seconds already, we won't convert it, we'll just leave it as it is. We'll simply just say total should be this equals the integer to seconds dot group. Then afterward, what this is actually doing here is it's converting each duration, let's say from hour, let's say for instance this over here, it's convert this 1 hour to seconds. It's also convert this 41 minutes to seconds. It's convert this 1 hour to seconds by simply multiplying it by 3,600. Then it's add it with the conversion of this minutes, this 41 minutes into seconds. Then it's also sum it with this final seconds over here, I mean 37. Then it will sum everything together and give an output which will be in seconds. So afterward, we can simply say this should return total. So we can simply run this function and apply it to our data set. Shift enter. Oops, what's that? Okay, let me close the bracket over here. Shift enter. All right, so let us apply this function on our data sets. Let's simply have another column over here called duration in seconds. This will serve as our seconds column. So we'll have df of duration. We are selecting the duration column here. Then we'll apply this function on it. We'll apply this towards, we'll apply the function, the duration to seconds function that we've declared already here. We'll apply it on this duration column over here. This. So that will be, let me simply paste that. So we can simply run this and see what we have. Shift enter. So let's view our data set and see what we have. Let's say df.add. Shift enter. All right, as you can see here, it has already been effected. The first entry over here, how to lie with data. The duration here is 5 minutes and 80 seconds. Converting 5 minutes to seconds by multiplying it by 60 and adding it with 18 seconds will simply give us 318. And also 1 million YouTube play button unboxing, as in converting this 7 minutes and 40 seconds in seconds, we add up to 460 seconds. All right, after doing this, let us move ahead and calculate the engagement ratio. Engagement ratio here is the ratio between likes and views and comments and views. We'll calculate the engagement ratio like per views and also comments per view. So for us to do that, we can simply calculate it by simply adding another column to our data set called, let's call this likes per view. and this is just simply the ratio between likes and view. We'll simply divide that by views. This will give us the engagement ratio like per views. Then the second, which is a comments per view, we can simply edit this and call it comments per view, which is the ratio between the comments divided by view. So let's simply run this and see what we have. Shift enter. All right, now our data set will be looking somehow like this. Let's say df.add. All right, as you can see here, this is the like per views for this particular video, and also the comments per view for this particular video. This first video over here, the ratio of the numbers of like per view is about 13%, while the comments per view, it's about 1%, and so on for the other videos. All right, so we can move next to the summary statistic for the views, likes, comments, and duration. The summary statistic will give us an overview on how the distribution of this video metrics looks like, whether they are right skewed, whether they are left skewed, the minimum, the maximum, whether there's an outlier in there or anything. So for us to achieve this, let us simply say declare a variable called numeric columns. Our numerical columns here includes the views, likes, the comments, the duration in seconds. Those are the major metrics that we want to view. So let's simply extract them out. Let's say this is views. All right, so we can simply call another variable called summary, and for this summary we'll simply select all these numerical columns that we've highlighted previously, that we've declared previously in the numeric columns. I'll simply copy this and paste it here. Afterward, we'll use that method called describe, the describe method. Let's simply call this and see what we have. Shift enter. All right, as you can see over here, this is our statistical details or statistical summary of our matrices. Take for instance, as you can see, the count over here, they are 355. From the views, we have 355. Likewise, the likes 355, and also here also we have 355. We can simply rearrange this so that all of them will be in the same format, instead of the views being in multiple of 10 raised to power 5, 10 raised to power 2, 10 raised to power 5, 10 raised to power 4, and the likes. We can simply just change that by applying a lambda function, which will approximate this to, let's say, 2 decimal places. Let's say apply map. So let's use a lambda function for that. Let's say x such that if you have something like this, so we'll do this to 2 decimal places. Then let's try on the shift enter. All right, now as you can see, now all of them are in the same in the same format. When you look at the views column, you find that the numbers of counts of the videos, all true on views, on likes, on comments, on duration, seconds, are all 355. Whereas when you look at the mean, the average views on Alex channel is about 234,000. That's the average view. 134,000 average views, while the median over here is about 38,724. That shows that there are some outlier in the views distribution, because when you check at the median and the mean, they are not anywhere close. When you look at the mean, you find out that it's about 3 times the median, which that signals that there is some outliers in our data set. They are not normally distributed. Likewise, when you look through the minimum values over here, 297 views, that's the minimum views, while the maximum view over here is about 2.1 million, which is quite huge, and that signifies some of the videos on Alex YouTube channel have higher view than the others. Then likewise, when you check the top 25% over here, the views is about 137,000, which is somewhat closer to the mean, the average mean. Likewise, when you look at the standard deviation, you can guess that there is a very large spread between the mean value and the standard deviation value. The same thing also applicable to the likes. When you look at the likes, you find out that the likes here is about 3,282. That's the average likes on Alex's channel, while the medium here is about 1,378. This also shows that the distribution for the likes is somehow right skewed, because the value of the medium is quite is quite low compared to the mean value. Then also you find out that the maximum value here about 46,000 plus compared to the minimum value here, which is 40. That shows that there is huge outlier there, meaning that this shows that there are some videos that people likes on Alex's channel than others. There are some videos that the numbers of likes are quite huge compared to others. Likewise for the comments, same thing also applicable to it. About minimum of 3 comments, while we have maximum of about 4,000 plus comments. Likewise, the mean and the medium, they are quite huge, showing that there is a right skewed over there. Then the duration in seconds, the mean duration for Alex's video is about 1,742 seconds, which is equivalent to about 30 minutes video, whereas the maximum duration over here, which is 84,764, that is equivalent to about 23.5 hours, almost 24 hours, which is the video we saw the other time over here. This particular video, Ultimate Data Analyst Bootcamp, about 24 hours long. Alright. Next on is to find the distribution of the video's duration. Even though this has already given us some clue on the distribution of the video duration, from these duration seconds we can able to see some patterns over there, but we can simply visualize it to have a better grasp of how the distribution looks like. To do this, we can simply firstly convert from duration seconds to minutes for readability, because seconds is quite huge. So let's say this is let's have another column in our data set. Let's call it duration in minutes. Then this is simply duration in seconds. We'll divide that by 60 in order to convert from seconds to minutes. We divide it by 60. Then afterward, we'll plot that. So we can simply run this to visualize how the distribution looks like. So let me just say Shift Enter. Oops, what was that? PLT is not divine. Alright. Let's simply import all those libraries we'll be needing here. Let's say import matplotlib .pyplots as PLT. Then I also need Seaborn. Let's say import Seaborn as SNS. Then we're also importing, let's say, Pandas as PD, and import NumPy as MP. So let's simply run this again. Shift Enter. Alright, here's the distribution, how the distributions looks like. From this distribution, we can simply see that most of Alex's videos varies between, let's say, 50 minutes to, let's say, 150 minutes, like that. And also there are very few videos that reach 200 minutes. When you convert 200 minutes to hours, that's about 3 hours. And a very few videos add about 1,400 minutes, which is almost 23 plus hours, or the 24 hours video that we saw the other time. But most of his videos is in between, let's say, 50 minutes, 100 minutes, 150 minutes. This particular distribution shows that Alex only had about a very few videos that is of 1,400 minutes, which is almost 23 hours, like the likes of the videos we saw the other time. So let's continue. Next here is to find the top videos, top 5 videos by views. That is the most viewed 5 videos on Alex channel. Let's simply do this by using the n largest function. So let's say top view df dot n largest. What this function is simply doing is that the n largest function is simply arranging the videos on Alex YouTube channel in descending order. So let's simply say it should select the first 5 there, and it should group them by views, the numbers of views. So what this simply does is that it will select, after arranging the videos in descending order, that is from the largest views to the lowest views, it will select only the top 5 views. So afterward, let's say it should add the other titles, the views, the numbers of likes and comments on those 5 selected as in videos. So let's add the title column to this, likewise the views also, then the likes, then finally the comments. So we can simply run this and see what we have. Shift enter. All right, on Alex YouTube channel, these are the most viewed 5 videos, top 5 videos. The first here is the data analyst portfolio project, which is, it's had about 2.1 million plus view and about 36,000 plus likes and about 4,331 comments. That is quite huge actually. Followed by the free data analyst bootcamp, that's it's about 1.8 million view, 46,000 likes and 1,750 comments. Then down to the SQL basic tutorial for beginners, then how to become a data analyst in 2023, complete guide, then finally what does a data analyst actually do, which is about 1.0 million as in views. So these are the most viewed video on Alex channel. This particular insight that we are seeing here might serve as a guide for a YouTube content creator to know some of their videos that are performing well, in order to know how to replicate the standard or the qualities in those videos to their other videos, in order for them to have good, as in more views, higher comments, and higher likes on their videos. All right, let's move next to the next analysis over here. The top 5 videos by engagements on Alex YouTube channel. We want to measure the engagements here with respect to what likes per view. The engagements we are trying to measure here is with respect to likes per view. So for us to do this, we are still using the n largest function in Pandas. So let's say top engagements. So we say df n largest, the top 5 using the likes per view column, using the like per view feature. Then from there, we'll also select the title for the most engaged videos, the title and the like per views, So we can simply run this and see what we have. Top engagement, shift enter. Oops, like per view, not in index. All right, I think I had a typo over here. Likes per view. All right, shift enter. All right, here are the videos, Alex videos, that are mostly engaged with. Here are the top 5 videos that people engage most with. The first one is how to lie with data, about 13% engagement rate. Then also nobody cares, so just do it. It has about 10%. And here's another one over here. Even though it's just a link, we can simply check, we can simply look through that by saying, let's say, top engagements. Let's simply select what we have here. We have it's in 125. That's the number. So yeah, let's use the log function here. 125 and check the title for that particular video. title, shift enter. All right, here is it over here, youtube.com playlist. Okay, it's a playlist of video. We can simply check through it and see what we have. Okay, it's Alex data analyst bootcamp, which consists of several as in contents like the free analyst bootcamp, how to become a data analyst in 2023, SQL, MySQL for intermediates, data cleaning. Okay, it's just a mega playlist that consists of several useful contents like Power Query, SQL, Python, and the likes. All right, building a BMI. Okay, so that's it over here. It's also have it's people engage with this playlist very well. Also about 9% engagement. Then here is I think this will be a short video. It's also have as more engagements. Likewise, the free data analyst bootcamp for 2024, it's also have more engagements. So let's move down to the next exploratory analysis that we are doing, the correlation matrix between the performance metrics. That is between the views, the comments, the likes. For us to achieve this, let's define those matrices that we want to find their correlation. Whether does a video views correlates with the likes, or does its likes, if a video have a huge number of likes, does that correlate with the numbers of comments the videos will have? So let us check through those relationship. So let's say correlation matrix for this particular, for these features. So let's say views, we want to check for views, the likes, then likewise the comments. I want to know if they are correlated. Correlation table for that. Views with respect to likes, it's about 0.93, which is very high. It's a very high positive correlation. That is, it's very closer to 1. This simply means that there is some level of relationship between a video having an higher view and higher likes. A video that has an higher views tends to have high likes also. Likewise, for the comments and views, videos that have more view also tends to have more comments. This is about 74, almost as in approaching 1. They are positively correlated. That is, as one goes up, the other also what follows. Then let's check this also. Comments and views. I think we've already made mention of that. Then comments and likes. We can simply visualize this in an heat map to have a visual view for how the correlation distribution, how the correlation matrix looks like. So let's simply do that. Or let me just simply comment this out. So let's run that, shift enter. All right, here's the view how it looks like. As you can see, the views with respect to likes is about 0.94, very highly correlated. While the comments with the views, it's also highly correlated. That is, the more a video has a more view, that particular video tends to have larger comments. Also for the likes, whenever a video have more likes, it also tends to have what? Larger comments. However, correlation doesn't mean causation. There are many factors that can also drive the views, the comments, and the likes, depending on, let's say, for instance, the quality of the video, the values in which the videos also gives, and there are many factors, several factors that might be unknown. They usually call them confounders, hidden factors that might not appear. However, this just shows us on a level, as in on a surface level, that there are some correlation between views and comments, likes and comments. All right, let's move ahead to the next analysis over here, the quarterly view trends. How are people viewing Alex channel? Let's take, for instance, in the first quarter of the year, how many views does Alex channel attract? In the second quarter, how many views does Alex channel attract? All the way to the fourth quarter of the year. We want to visualize that from when Alex has started his YouTube channel, right, in 2019, if I'm not mistaken. We want to look at the pattern, the trend, how it's looking. If maybe there are some quarters that Alex do have more viewers on his YouTube channel than others. So let's simply do this. we'll be needing the published column here in order to extract the year and the month, which will be very valuable for this analysis over here. We'll be needing the year and the month. Like, take for instance, this is April 2025, this is March 2025, and the likes. Before we do this, let's simply convert the published column to date time format. When you look inward to the columns that we have in our data set, you find out that published is not in date type format, it's not in the right data type. It appears here as an object, whereas we need it as a date time format. So let's simply convert that first to a date time format. So let's simply say df published. We need this as in date time formats. We'll convert that to date time. df, let me simply increase this. All right, df published. All right, this will simply convert the published column to date time. If I run this, shift enter, oops, to date time. Okay, this is supposed to be in brackets, in parentheses like this, shift enter. All right, so let's recheck that, shift enter. Now we can see that the published column now is in date time format, which is the right format for that. Then after that, we'll extract the year month from the published column. We needed the year and the month in order for us to group them in a quarterly manner. All right, let us move to the next step. The next step here is to group all those published dates in quarterly manner. So let us simply achieve this by saying, using the published column, published, then we'll convert that to date. Then we'll use the to period function here. The period here is in quarter, so we'll pass in Q, that is quarterly manner. We'll extract it as a formatted string, so we'll change the type, as in the data type, to string formats. So we can simply name this. Let's pass this into another column called upload quarter. Let's say upload quarter. So let's simply run this and see what we have. Shift enter. Yeah, okay, no problem. Let's simply view our data set and see what we have. Shift enter. All right, as you can see over here, this particular video that is published on the 1st of April 2025 falls in the second quarter of the month, of the year, I mean, which is correct. Likewise, this, which is as in published in March 2025, falls in the first quarter of the year. Likewise, this also on 3rd March falls in the third quarter. We can view the remaining parts of the video also. Let's check those ones at the tail. Like this, that is published in January 2020. In January 2020, we can see that it falls in the first quarter of the year. All right, that's what this code here is simply doing. It's adding a column called upload quarter, which group these published dates in their quartile formats. All right, so now let us group by quarter and aggregate in order for us to visualize how Alex video behaves quarterly. We can simply say df.group. We can group by. We'll be using the group by function here. We are grouping by the upload quarters here. Upload quarter. Seems like there's an R here. All right, then we'll be using the aggregate function. We'll aggregate this based on the views. For the views, this is the main feature that we want to measure, so we'll sum them up. That is, we want to know the total numbers of views per quarter. So we simply sum this, comma, then the likes per views, we can simply just as aggregate this using the mean value, then also the comments per views, we can simply also as an aggregate this with the mean, then finally we can just reset the index here for the data frame. We can simply pass this inside a variable called, let's say, quarterly stats. So let's view this and see how the table looks like. Control C, Control V, Shift Enter. Alright, as you can see, here is the views, how it looks like. Starting from 2020, the first quarter, this is the numbers of views Alex channel draws. That is from January, February to March. Likewise, in the second quarter of the year 2020, these are the likes, these are the views, like per views and comment per view. Down to 2025, which we are here. The latest video that Alex released has about 297 views at the time of the production of this video. Then likewise, in the first quarter here, he had about 138,000 views on his videos. So let's simply visualize how this looks like in order for us to have more graphs of that. So let's simply visualize this. So we can simply use this to visualize how views looks quarterly. Shift Enter. Alright, here's the distribution. As you can see over here, it has some rise and fall as expected. When you look to this particular quarter, 2021, the second quarter of 2021, Alex has the highest view, more than as in 5 million view, because these are in millions, more than 5 million views in the second quarter of 2021. Then followed by the first quarter of 2023, it still has as in some high view, about close to 5 million. Then afterward, this has been decreasing, like in 2024, the fourth quarter, like in 2023, I mean, in the fourth quarter, Alex had about, let's say, close to 3 million views on his channel. And this decreased drastically between 2023 fourth quarter to 2024 third quarter, before Alex channel witnessed another rise of about, let's say, 1 million plus view. However, in 2025 views, quarterly view of Alex channel is very low compared to the previous years. Take for instance, like 2020, the first quarter, he had about, let's say, 4 million plus view. Then for 2021 first quarter, he had about 2 million plus view. Then 2022 first quarter, also close to 3 million views. Then 2024 over here, 2024 first quarter, also more than 1 million view, although it has been reducing, as in decreasing drastically down from 2024. Why 2025, Alex channel had the worst as in views, numbers of views in the first quarter of 2025, which is about, let's say, how many views is that? 138,000 views, which is quite low compared to the previous years. So this might give an insight for Alex in order for him to as in replicate what he has done in, let's say, in the first quarter of 2020 or first quarter of 2021 or as in first quarter of 2022 also, in order for his channel view trend to shoot up again. Alright, that's it for that. Let's move on to the next insight over here. The keyword top 10% viewed videos. We want to know the keyword that is ranking higher in those 10% most viewed videos in Alex channel. Let's call this top 10%. Here also we'll be using the n largest function. We'll simply select the top 10% of Alex video. So then we'll convert that to integer. Let's say the length of the data set, that is the total number, which is 355, right? We only select the top 10%. To do that, we multiply this by 0.1, comma. We want to sort the data set with respect to the numbers of views. So we have something like this. Then from there, when we look at this, you see what we have here. Let's see what we have here first. Shift Enter. Alright. These are the top 10% most viewed videos on Alex channel. Starting from this, data analyst portfolio project, SQL, exploratory analysis, about 2 million plus, followed by free data analysis bootcamp, 1.8 million plus, and the likes. So here we want to extract those keywords that are making this ranking as high as this. So let us find those most common keywords in the top 10% performing videos on Alex channel. So for us to find those most common keywords in the 10%, the most top 10% performing videos on Alex channel, let's say for word, we'll be using the find all function in regex by saying find all. Now we are dealing with word, so we select all words we look through each titles in the data set. So this simply does that for us. We look through the title. Then this also have another nested loop over here. For every title that we've selected from using this line of code, for each title, if it exists in our top 10% data set, that is this data set over here, if those words also exist here, that is whether it might be this, it might be this, it might be that, and everything. So if it appears in the title over here, if they coincide, what should happen? This should return that particular word in a lowercase. So let's simply put this in a list. All right, so let's name these words. As you can see, this simply selects all those words that are in our data sets, our total data sets, and compare them with those words in top 10% data sets. So it compares them with it and extracts them out. Take for instance, if we look through this, we have data analyst, portfolio project, SQL data exploration, which is equivalent to what we have here. Likewise, some of them like this free data analyst bootcamp, and everything like that. It's extracted all those words out. So we need to count them out, like in terms of data here, data also exists here. So for us to count it out, we'll be using the most common function in our counter library. Let's simply say from collections, import counters, shift enter. So now counter, then we pass in the words that is here, over here, as in this our word variable. We pass that in. Then we use the most common function. That is the most common, let's say the most common 10 keywords here. We can simply run this by saying shift enter. And these are the most common keywords in Alex top performing videos. Like the data, as in the word data, the keyword data, it appears about 23 times. Then this particular keyword also about 17 times. Analyst also 16, beginners 12, in 12, and the likes. This serves as an insight for a YouTube content creator in selecting their words, in selecting their keywords. You might decide to put it in as a title for any of your videos. Alright, so let's move ahead now to the next section of the video, which is hypothesis testing. We'll be testing basically 2 hypotheses in this video, which include shorter videos have higher engagement, videos published on specific days perform better, while the third one over here, tutorial videos gets more views than career videos, career advice videos. It will serve as our own personal assignment that we'll do it ourselves. So moving to the first hypothesis here. Here is a null hypothesis, that is the initial assumption that we are assuming here, that on Alex's YouTube channel, his shorter videos have higher engagement than his longer video. That's our null hypothesis, our base hypothesis. So we want to prove this. If we will fail to reject this, or we reject this particular null hypothesis, you can simply test for this hypothesis using the correlation test. Perform some testing if there's any correlation between the duration of the video and likes per view, or if there's any correlation between the duration of videos and comments per views, because those are the two metrics that we are using here in this analysis to measure the engagement, the like per views and the comments per views. So we can simply use the Pearsonr rank correlation method in order for us to verify this hypothesis. Let's simply import the Pearsonr ranking correlation from scipy.stats. So we're importing the Pearsonr correlation, shift enter. Then here we'll be passing into two variables. We'll be testing for the correlation between those features, that is the duration and like per view first, and the second feature, the duration and the comments per view. Aside that, we also find out their p-values in order for us to know their statistical significance. Alright, so let's firstly check the correlation and the p-value between the duration in seconds and the like per views. Let's say Pearson. We're using the Pearson function. The duration, which we've converted earlier on in seconds. We want to check the correlation and the p-value between these two features and the likes per view. So you can simply put this inside a variable. Let's call it the correlation of likes, because this will return two values, two results. So let's simply declare two variables for that. One which will be the correlation, as in the level of correlation, and the other one will be the p-values. So let's say this is the p-value of likes. We can firstly check this, or simply let's do for the second one, for the comment. Let's see, Ctrl V. Then this second one should be for the comments. And this should be the p-value for the comments. Then this will be the comments per view. Alright, so we can print out this. We can simply print out this, the correlation of likes, comma, that of the p-values also, the p of likes. Likewise for the second one here, the correlation between the comments per view and the p-value of comments per view with respect to the duration comments. So let's simply run this cell and see what we have. Shift enter. Alright, here's the results. The first result here is our correlation, while the second result here is our p-value. Whenever you are using p-value, you have to state your level of significance first. Actually, you have to determine the level of significance in which you want. The popular one is the 0.05, that is 5% significant value. If the p-value is less than 0.05%, you can simply say there is correlation between the duration in seconds and the likes per view. Whereas if it's not, we simply reject the null hypothesis. For better interpretation, let's say if the p-value for, let's say for our likes, if it's less than 0.05, which is our level of significance, if this is less than that, let our result return, let's say significant. There's a significant correlation between the video length and the likes per view ratio. And if not, else it can simply return, as in can simply print no significant value or no significant correlation for like per view. Alright, Then we can also simply do this also for the second value, which is the comments per view. The only difference here is that we'll change this to comments, then the shift enter. As you can see here, this is the correlation. There is a negative correlation which is almost zero. That is, negative 0 here means that there is no any correlation between the duration and the likes per view. Likewise, for the comments per view, there's no any correlation between duration of the video and the comments per view, because it's almost zero over here also, like negative 0.0089 for the first one, negative 0.000999, like that. Whereas for the p-value, the p-value here is greater than our level of significance. Level of significance that we've declared to be 5%. Here we have about 0.985, which is far greater than almost 1, which is far greater than 0.05. Likewise, for the comments, it's also about 0.86718, like that, which is more higher than the 0.05, which is our level of significance value that we declared. This shows there's no any significant correlation. Irrespective of how the length of the video is, it has nothing to do with the numbers of likes. It has nothing to do with the numbers of comments or the numbers of views. That means for Alex channel, his duration of videos has nothing to do with whether people will like it or people will comment on his video or people will view his video. Simply put, this particular hypothesis will be rejected. We will reject this particular hypothesis that shorter videos have higher engagement. Let's move ahead to the final hypothesis here that we'll be testing, which is the video published on specific days perform better. These are null hypotheses. We want to test if this particular hypothesis is correct or not. For us to do this, we'll be using the one-way ANOVA to test if this particular hypothesis will be rejected or will fail to reject it. So let's import the library from the SciPy stats library also. Let's say from SciPy.stats import one-way, F1-way. What we are trying to do here is to compare some specific days that Alex video gain more views than the other. Take for instance, maybe Alex videos, any video that Alex upload on Mondays usually have maybe a larger view compared to the one he upload on, as in he uploads on Tuesday or Wednesday. So we need to extract days of week, and we can simply extract days of weeks from the published column. When you view the published column over here, df head, I mean this particular column, we can simply extract the day of week using the day of week function in our pandas. So I will simply do that by saying df published dot dt, then we'll use the day of weeks, we'll extract the day of weeks out. So we can simply call this day of week, shift enter. So when we view our data set now, let's say dot head, shift enter. So as you can see, this is day of week D. This is F, shift enter. Alright, now like this we can see the day of week has been extracted from the published column. Okay, that has been duplicated. I can simply just drop one of them off. Say df.drop. We are dropping these columns, this particular one here. Let me simply highlight it. So we are dropping this and we'll put it back to the df, shift enter. Alright, then let's run this again, shift enter. Alright, so these are day of week. As you can see, it is a number 1, 0, 2, 3, 4, from 0 to 6, ranging from 0 to 6. 0 means Monday, 6 means Sunday. 0 for Monday, 1 for Tuesday, 2 for Wednesday, and the likes till Sunday. 6 means Sunday. For instance, this first video like this, which is 1st of April 2025, Alex released the video on Tuesday. Monday means 0, Tuesday means 1. He released the video on Tuesday. We've extracted that out. The next thing here is to group the views by days. All Mondays views will be on one side. All Tuesday views also will be accumulated in a side. Then we'll try to visualize that and apply some ANOVA test on it to test for that. So we can simply do that by having the days list over here. We'll have a day. So here's our day list. Then we can simply say the grouping. We can use a for loop for that. Let's say day groups. Let's call the variable day groups. Let's say for I'm using a comprehension list over here. Let's say for I in range of 7, that is, it will loop all through these numbers from 0 to 6, right? In range of 7, what should it return? It should return something like this. Let's have a list like this. Day of week should return day of week. Let's say day of week that is equivalent to I. One, and also it should return the numbers of views. So let us simply run these day groups and see how it looks like. Day groups, shift enter. Oops, what's that? Day groups, shift enter. All right, here's what you have. This first row over here, this first column over here simply denotes the index, while these other values here simply denotes the views, the numbers of views. Take for instance these two, that's the second index over here. The numbers of views there is 6,901, that is 0. It starts from 0, counting it from 0, which is Monday. We are starting the day of week here using Monday. We are not starting with Sunday. Monday 0, Tuesday 1, Wednesday 2, downward like that till Sunday, which is equivalent to 6. So another index here, which is index 78, that is number 78 over here. The numbers of views there is about 27,000. Likewise, the remaining also. That's how it counts everything. Afterward, the next one here is the Tuesday views. The Tuesday starts from this index 0, which is the first index here, which is about 297 over here. And as you can see from here, this is the index here. This is the day of the week, which is 1, which is equivalent to Tuesday. So that's how it counts for all of the days till Sunday. So that's what this particular line of code is trying to do here. From there, we can simply go ahead to do our test, our ANOVA test. So let's say F starts. The ANOVA test usually brings two variables, two results, which include the F statistic and the P values. So the F statistic, we can simply denote it with F stats, and the P values also, let's say this is our P value. So we are using the F1 way ANOVA. The reason we are using ANOVA test is because the grouping here is about 7 groups. We can't use t-test for that because t-test is just only restricted to groups. Here we have 7 groups, that is 7 days of the week. And aside that, ANOVA test is also good in controlling type 1 error, that is false positive error. It handles false positive error effectively. So let's continue. We have our one way. Then we'll pass in all the values here in day of week, in the day groups. Then afterward, we'll print out the values here. We're printing out the F stats and the P values. Shift enter. All right, here is it. This first value here is our F statistical value, and this our P value here is as in this second value here is our P value. Take note, as I said earlier, define your level of significance first before doing any analysis so that you won't be biased. Here like this, we're supposed to have defined our level of significance before even running the test. That's my bad. However, we are defining we'll be taking our P value here to be 0.05, which is 5%. Anything less than, if our P value is less than 0.05, we fail to reject our hypothesis value. That is statistically significant. All right. Looking at this, we find out that this particular value 0.001 is quite less than 0.05. Our P value here is less than our level of significance, meaning that this particular hypothesis holds. What's the hypothesis? The hypothesis here that we are trying to verify is that video published on specific days on Alex channel perform better than other, meaning that this particular hypothesis, null hypothesis, we have to look inward to it on this to know those particular days that are more significant than others, that have more engagement than others. So for us to pinpoint the specific difference here, we're performing some post hoc tests on our analysis. So we have to further our analysis by pinpointing those specific difference within those days, within the days that we are comparing, that is day of the week. Here we'll be using some post hoc tests. Specifically, we'll be using the Tukey HSD, that is Tukey honestly significant difference as in tests, in order for us to further our ANOVA significance. So we'll simply say if, let's declare a function here. Let's say if, or first let us import that library. Let's say from our start model library, from start model dot start dot, we are using the multi com over here, import the Tukey HSD, shift enter. All right, so let's say if our p value is less than 0.05, let's declare a variable called Tukey. Then we say the pairwise Tukey HSD. Then we'll pass in some parameters. We have the end-dog parameters, we have the group parameters, and the alpha. The alpha here is our level of significance, while the groups is what we are trying to, as in the days of the week that we are trying to focus on. Then the end-dog here will be the views. That's what we are comparing. So we'll say the end-dog here is our views, and groups here is our day of week. Then finally the alpha here, that's 0.05, that is 5% level of significance. Then afterward we can print out the Tukey summary. Let's print out this Tukey.summary, shift enter. All right, here's what we have for the summary for the Tukey. As you can see, this is the groups, group 1 and groups 2. This is the mean difference between the views. This is the p adjusted value, the lower, the upper, and the reject. What this table means is that 0 here simply denotes Monday, 2 denotes Tuesday, down to 6, which denotes Sunday. 0 and 1 here is simply 0 and 1 over here is simply comparing statistical significance between any videos being uploaded on Monday and Tuesday. After comparing it, it later returns false, meaning whether Alex uploaded his videos on Monday or Tuesday, it doesn't have any relationship with the level of engagement to that video. Likewise, it also compares 0 and 2, 0 and 3. All these days doesn't have any significance, as in any statistical significance value. However, when you look at 0 and 6 over here, this particular column, this particular row here returns true. That is, we can't reject the null hypothesis for Alex video being published between Monday and Sunday. We can't reject that. Let's still go further and check another value, another row over here, which is 1 and 6. I think we are seeing the pattern. When you look at another pattern also over here, 2 and 6. Likewise, 3 and 6 over here. And also 4 and 6 and 5 and 6. You see that most of all these days related with Sunday, comparing days with Sundays, the values that is returning are true. This simply means using the current Alex videos on his YouTube channel, whenever Alex uploads his videos on Sundays, it's have higher engagement value compared to other days. So from here, we can simply deduct that insight that Alex should keep uploading any of his new videos on Sundays. This is simply because any video he released on Sundays simply have what higher engagement compared to other days. However, there's something crucial here. Whenever you are doing a statistical analysis, if your statistical analysis is statistically significant, that doesn't translate that in real world it is what it's also significant in real world. You have to compare it, compare other factors, put all as in look inward to other factors that might be affecting that particular as in movements. However, there's another ways of visualizing the numbers, the days of week with respect to the views, for us to have a better grasp of what we earlier said, that Alex videos performs as higher engagement or higher views on Sundays. Let's simply just plot the days of week with respect to views. Let's have a box plus for that. The day of week, then y-axis, let's give it, that is views. Then we are using our data, which is df. So you can simply visualize this to have an overview of what you are saying. Shift enter. All right, here as we can see from this visual, if you look at the box plot over here, you find out that Alex has an higher view of about, let's say, close to 1.5 million views for his videos being uploaded on Sundays, compared to other days like Saturdays, which he had as in a very low videos on Saturdays. The videos usually as in have a very low views. Then on Tuesdays, there are some very outliers, like about 2 million plus. There are many outliers over there for his uploads on Tuesday. However, this is the one we are more concerned with on Sundays. As you can see, out of all these box plots over here, the medium and the maximum over here in this box plots, you can see that it's higher than compared to others. And on Saturdays, that's the worst performing as in content ever for Alex. So all this gives an insight for Alex channel. Whenever Alex wish to upload any content, he might take this into consideration. However, as I made mention earlier on, that statistically significant values doesn't mean in real world it is that significant. We have to compare several factors, put several factors in place in order for you to establish your findings appropriately. That's where we stop for this project. Kindly like, share, and subscribe to Inside Data Academy for more content on data analysis, data science, or data engineering. Thank you for coming this far. See you next time.